So today we're getting ready for the quiz or test, which is tomorrow. And here's the first kind of problem we need to talk about: expected values. Expected values, there's 4 letters that I've asked you to remember. What are they? PPA, good. And the P is possibilities. And what's the other P? Probability times the amount, and then you, all right, good. So what are the possibilities on these warranty things? There's always 2. Breaks or works. Okay, and work, oh, can't write a W today. Works, breaks. I'd like you to make a little tree for me and solve this problem. I'm going to pause this while you do. So there's our probabilities that it's going to work or break. Then that came from the 5 out of 2,500 that they break. Then the amount you get, if it works, is nothing. In fact, it's worse than nothing. You've paid $10 and you didn't need to. So that's a -10. The breaking, if it breaks, we get a new TV, which is worth $2,000, minus the $10 for the warranty. Add it all up. So when it adds up to -6 like this, what does that mean? You lost money. What if it had come out to 0? It would have been a fair deal. You would have bought the warranty and it was worth exactly what you paid for it, if it's 0. So what if it comes out positive? It was a good deal. You made money above and beyond what you should have made. All right. And remember, expected value you shouldn't ever expect. You will never just lose $6 on this deal. You'll either lose all $10 or you'll make lots of money on the deal. And it averages out, though, on average to $6. So it really should be an expected average value or something like that. All right, this next one's also an expected value, and frankly, we're just going to save time by not doing it. We'll just talk about it. We do all the possibilities, and then we take all the probabilities and times the amounts you get. Here's the hardest part. What's the probability hitting that one? 1/8. And in case you can't tell, it's because it's 1/4 divided in half. You know what I mean? That was what makes it 1/8. All right, so 1/8 for that one, etc. All right, let's move on. This one is a weighted average, and the way I would always set them up is like this. I'll do one, then I'll have you do one. You just write down all your weights: 0.15, 0.30, 0.25, and 0.30 again. And that has to equal what you want. And what I want is 90%, 0.90. And then I have to go back in and put in all the things that I actually got. On this problem, it says I got 80% on papers. So that's 0.80 on the papers part, which is 15%. It's right there. And then I got 92% on the quizzes, 0.92. Plus, I got 75% on this. And the last thing is I don't know what I'm going to get there, so I put an N. Remember that? You set up this one, please, and I'll pause while you do that. So we can do this one the same way as I did before, and I'll just throw in my new numbers in front of it. I need to get, actually, all those numbers would have been okay, wouldn't they? Let me go back and leave them in there. It's just I have to just change one thing. I have to change that to a 65%. That's all I would have had to do, because I got the same scores. I just want a lower grade for the final. So you end up with N equals 22%. All right, let's talk about this next kind, because it is different. It is about the Olympics, which is kind of timely. 135-meter jump, 126-meter, and 107-meter, and he has one more jump. What do I put for that? N or X or whatever. Okay. And then if I want an average, I just add them all up and divide by how many there are. Is this a weighted average? No. In the Olympics, they could weight the averages, like maybe they want to put more pressure on you and they could make your first jump worth like 50% or something. They could do that, but they don't weight the averages. They keep it simple. They just average your 4 jumps. Okay, so if I take 135 plus the 126 plus the 107 plus the one I haven't done yet, and I divide by 4, I want it to average 125. Really important that you complete it. You can't just write the first part. You have to say equals 125, and then you can actually solve it. How do I start? Multiply by 4. If I multiply both sides by 4, this one goes away, and this one becomes 500 equals, and then all of that stuff. Then I add up this part right here, and I subtract it from both sides. Final answer, I think, was 130 something. 132. Excellent. All right. All right, so that's another kind of average. This one is a systems problem. Basically, you have to write two equations. That makes a system of equations. If I have two variables, I need two equations. What if I have three variables? I need three equations. All right, so go ahead and get this one a try. I'll pause while you do. Okay, there's our two equations. And now I'm going to subtract p from both sides and get r equals 45 minus p. And then I'm going to stick that in to wherever I see r, which is right there. So I'm going to go 150 minus 3, and instead of r, I'm going to put 45 minus p, and then plus 4p. Now, what's good about this equation? Or first of all, that's not an equation. There, equals. Now it's an equation. They all have all p's. Good. But once I've got it down to one letter or one variable, it'll be easy from there. Has somebody solved it? What does p come out to? 15. And if p is 15, then I can go stick that back into any of these equations, like maybe that one. And I can go r is equal to 45 minus, the p is 15. 45 minus 15 is 30, so r must be 30. All right. Raise your hand if you're confident on that kind of problem. Okay, good. Moving on. Next kind of problem. This one of those rate time things. What do you make for this? A chart with distance equals rate times time. Everybody, try to make the chart for this one. The dirt chart. DRT. Billy, Bobby. Okay, on these problems where somebody's going to catch up to the other person, what do we know about their distances? They're the same. Because even if they left at different times, they end up catching the one catches the other means that they went the same distance, as long as they drove on the same roads and everything. So D must be the same as D. The rate, Billy's 66, and the other guy's going 12 faster, so that means 66 plus 12, 78. That next one, if you don't know it, I put T. I don't know it, so I put T. And then you got to think this through. Who's been on the road longer, Billy or Bobby? Billy's been on the road longer. So that means whatever I put here, it better be smaller, right? Because the other guy went farther. And so this needs to be smaller. So I take T and do what? Minus how long? 2 hours. Because he started 2 hours later. Okay? There's your equations. Has anybody already multiplied them all out and solved them? Bet somebody probably has. Guess not. Oh, T equals 13? All right. I agree. Now, that is not the answer, though. And this is a good moral of the story thing. Sometimes when you solve it, you don't get what you really want. T is 13. That's Billy's time. What do they ask you for? Bobby's time. Bobby's time we got to find right here. And so we take 13 minus the 2 and get 11. Remember, he was on the road 2 hours less. So Bobby's is 11. Billy's would have been 13. All right, moving on. Number 7 is a projectile motion. See if you can remember that equation. It always starts with y equals, remember? Negative 4.9 x squared, and then there's some more stuff. See if you can remember that. I'll pause while you do. So there's our equation. Next, we're going to pull up this Smart View. I put in my equation, which is right there. And then I go to second, calculate. Do this with me on your calculators. I'll pause for a second while everybody gets their calculator. So if I want to stick in a number for x, I choose the first one, value. And x equals, what did they ask? Time 6. So I stick in a 6 there and I hit enter. Did you get 89.6? Good. Next thing, I will go back to the same spot. Second, calculate. Calculate is right above trace. And I can find the 0. Arrow down to 0, hit enter. And it wants me to be on the left side of the 0. I already am, so I hit enter. Now I'm going to go to the right side of the 0. Remember, the 0 is the x-intercept. I go all the way past that, and I hit enter. And then it says guess. I hit enter one more time. And I have y is 0. That's what the point is. That's the x-intercept. And the x is 8.5. So that means the time's about 8.5. And I do one more, and that is the maximum. And maximum on this one, I go to the left side of it. Get the little spider off to the left of the max. And hit enter, and then go to the right side of it, and hit enter one more time, and it comes out to 3.67 for X, and Y is 116.